Yes, welcome to this lesson in which we want to look at acylation of benzene. Now, acylation of benzene somehow confuses students with alkylation of benzene. The two reactions sound similar, but they are totally different. Alkylation involves addition of an alkyl group to the benzene ring. An alkyl group has one hydrogen atom less than an alkane. Okay, so for example, if you have an alkane like methane, then its alkyl group is called methyl group, and therefore its formula will have one hydrogen atom less. Okay, so methane is CH4, but methyl group will be CH3. That is an alkyl group. Okay, now an alkyl group in alkylation is the electrophile. Okay, but in acylation, like we shall look at a different electrophile we are adding there, which is actually called acyl group. From acylation, the electrophile we are adding is an acyl group. We shall look at the structure of that electrophile. Okay, now let's continue. Now, alkylation simply is the reaction of benzene with acid halides. We shall get to know what acid halides are, and we have a general formula for acid halides here. You can see that it has a hydrocarbon chain. This R here represents a hydrocarbon chain, any of any length. Okay, then we have an alkyl, we have a carbonyl group, and then we have a halogen atom attached there. Okay, so that is an acid halide. It has a hydrocarbon chain, a carbonyl group, and a halogen atom from acid halide. Okay, so when benzene reacts with these acid halides, it forms aromatic ketones. Okay, aromatic ketones, we shall look at how their structure looks like. Okay, now we have already defined that the reaction of benzene with acid halides, which have this general formula to form aromatic ketones, that is acylation. Now, the condition or the conditions for this reaction to take place are the following. Please note them. 1. This reaction only takes place in the presence of a halogen carrier. This is one reason why most times students confuse it with alkylation, because both of them involve utilizing a halogen carrier. Okay, but now the electrophiles differ. Okay, good. So the one condition is presence of a halogen carrier. Then the other condition is a temperature of 50 degrees Celsius. This is also very important. So when you are performing that reaction, you must have a halogen carrier, and the reaction takes place at a temperature of 50 degrees Celsius. Okay, so it involves, acylation involves addition of an acyl group. This is the acyl group we are talking about, and it looks like this. It has a hydrocarbon chain of any length, which is R, and a carbonyl group. This one is what we are calling the carbonyl group. Okay, good. Now, when a acyl group adds itself to the benzene ring, then we shall say the benzene has been acylated. Okay, okay, good. Then an example is here, a general example where you are having benzene reacting with an acid halide. This is an acid halide, a general formula for acid halides, in presence of a halogen carrier. Now this X here represents any halogen. Okay, this could be chlorine, this could be iodine, bromine, okay, all those halogens. Then what do we form? We form an aromatic ketone. This is how aromatic ketones look like, okay, in which we have the carbonyl group. The carbonyl carbon is directly attached on the benzene ring, and then we have the side chain being the hydrocarbon chain. Okay, so you will see that all the products are going to be in this form, where this group, which is the carbonyl group, is attached on the benzene ring, and then we have a side chain there of any length. Okay, good. Now, acid halides. How are acid halides formed? Acid halides are formed when carboxylic acids react with phosphorus pentahalides. So when you have a carboxylic acid reacting with phosphorus pentahalide, pentahalide means that there are 5 halogen atoms. Okay, for example, phosphorus pentachloride. Phosphorus pentachloride, meaning that it has 1 phosphorus atom and 5 chlorine atoms, or phosphorus pentabromide. Okay, so when you have phosphorus pentahalide reacting with a carboxylic acid, we shall form an acid halide, and of course these other inorganic products which are not of our interest. Okay, for example, if you add here phosphorus pentachloride, what would you think the product here would be? It would be, when you have now this X, which was representing the halogens, has been replaced with chlorine. So this will now be R C O Cl. That is, if you add here phosphorus pentachloride, if this was phosphorus pentachloride, okay. So the acid halides are formed when phosphorus pentahalide reacts with carboxylic acid. Okay, good. Now this is an example. These are some examples of acylation reactions. Okay, you have here, number 1, benzene reacting with ethanol chloride. Ethanol chloride is an example of an acid halide. How do you notice that? You can notice that this group, which is the carbonyl group, is there. We have the halogen atom, which is now chlorine, and then the hydrocarbon chain. This is now an acid halide, which is called ethanol chloride, and it is reacting with benzene in the presence of an halogen carrier, which is called aluminium chloride. Very important, at a temperature of 50 degrees Celsius. Then notice what happens really. Very interesting. You realize that the carbonyl group, like we said, this carbonyl carbon is the one that is now attached on the benzene ring. Of course, the oxygen atom is attached on that carbon atom. Then this chain, this hydrocarbon chain, is this one here. This